In this video, we're learning how to solve compound inequalities, and we pretty much solve compound inequalities the same way that we solve normal inequalities, but some of them just look a little bit harder because they may have like 3 parts, like these 2 examples. So I'll show you guys how we can solve these. So if we look at example 1, we have -4 is less than or equal to x minus 5, which is less than 7. So when we're solving an inequality that has 3 parts like this, what we want to do is try to isolate the x in our inequality, and anything we do to one part of our inequality, we have to do to all 3 parts. So we have x minus 5. So to get rid of that minus 5, we're going to add 5 because it's the inverse operation, so the same way that we solve a normal inequality or equation. But because we're adding 5 to the middle, we have to add it to the left and to the right. So on the left, -4 plus 5 is going to give us a +1. So we have 1 is less than or equal to. In the middle, the -5 and the +5 cancel out to 0, so we're left with x. And on the right, 7 plus 5 is 12. So we get that 1, or x, is greater than or equal to 1, but is less than 12. So this is saying that x is greater than or equal to 1 and x is less than 12. So it's got to fit both of these restrictions in order to be a solution. So now we're going to graph this on a number line. So we'll start at 0, and I'll just go up by 2s to make it faster. And we just have to get up to 12. I'll actually go up to 14. I'll just go 1 higher. So now we know that x is greater than or equal to 1. So we have to put a closed circle at 1 because x can equal 1. X is less than 12, so it can't equal 12, so we're going to put an open circle. And we know that both of these need to be true, so we only want to highlight what's in the middle of both. So this is x is greater than 1, but it has to be less than 12, so we have to stop at that 12. So that's how we graph that solution. Let's take a look at example 2, which is 6 minus 2k is greater than -10, but less than or equal to 2. So again, our goal is to get the variable by itself. So we're trying to get k by itself. So we need to get rid of this 6 and -2 in the middle of our inequality. We want to use reverse PEMDAS the same way we solve normal inequalities or equations. So we're going to get rid of this +6 first by subtracting 6 from all 3 parts of our inequality. The left part, -10 minus 6 is -16. We have less than. In the middle, 6 minus 6 is 0, so we're left with -2k. And is less than or equal to 2 minus 6 is -4. And now we have to get rid of this -2 that's being multiplied by k. So we want to divide -2. We need to divide all 3 parts by -2. On the left, -16 divided by -2 is +8. And now we have to remember that when we're dealing with inequalities, anytime we multiply or divide both sides, or in this case, all 3 parts of our inequality by a negative number, we have to flip the inequality signs. So this first less than sign turns to a greater than. In the middle, -2k divided by -2 leaves us with a k. We flip this next inequality sign. And on the right, -4 divided by -2 is +2. And I'm going to rewrite this the other way because I think it'll only make more sense. So 2 is less than or equal to k, which is less than 8. So either of these are fine. I just think the right one is a little bit easier to understand. So basically, this is saying that k is greater than or equal to 2 and k is less than 8, so it has to fit both of these restrictions. So now we're going to plot this on a number line. So 0, 2, 4, 6, 8, 10, 12. So k can equal 2, so I'm going to put a closed circle at 2. K cannot equal 8, so I'm going to put an open circle at 8. K is greater than 2, so that's going to be shaded to the right. K is less than 8, so that's shaded to the left. So k is between these two, so we're going to shade it like this. And now we're going to go through a couple examples that are OR inequalities. So for these next two examples, we're looking at compound inequalities that are OR inequalities. So the first two we just did were AND inequalities, and they're typically written in three parts like we saw, but OR inequalities are written as two separate inequalities. So we're just going to solve these as two separate inequalities, and then we'll graph our solutions on one number line. So if we take a look at example 3, we have m minus 4 is greater than 16, or 3/5 of m is less than 9. So let's start by solving m minus 4 is greater than 16. We're going to solve this by adding 4 to both sides of our inequality to get that m is greater than 20. And we'll solve 3/5. M is less than 9. We're going to divide both sides of our inequality by 3/5. On the left side, anything divided by itself is 1, so we're left with 1m or m. On the right, we have 9 divided by 3/5. Remember that when we divide fractions, we're going to multiply by the reciprocal. We're going to use keep, change, flip. So we'll keep the 9 as it is, but I'm going to make it into a fraction, 9 over 1. Change division to multiplication. Flip the second fraction upside down to become 5/3. And now I'm going to cross reduce. So I'm going to divide 9 and 3 by 3. 9 divided by 3 is 3. 3 divided by 3 is 1. And now when I multiply straight across, I get 15 on the top and 1 on the bottom, which is just 15. So I'm going to bring this answer down here. So I get m is greater than 20, or m is less than 15. So now I'm going to show you guys how to graph an OR inequality. So we're going to put some points on a number line, do 14, 15, 16, 17, 18, 19, 20. So we have the m is greater than 20, so it can't equal 20. So we're going to put an open circle at 20, and we're going to shade to the right. So this is an OR one, so m can be on this part of our graph shaded to the right of 20, or m can be less than 15. So it can't equal 15, so I'm going to put an open circle, and it can be less than 15, so I'm going to shade to the left. So OR inequalities typically have a gap in the middle of their graph, whereas AND inequalities are typically just filled in between the two numbers we find. So moving on to example 4, we have 3x minus 6 is greater than or equal to 9, or negative 7x is greater than or equal to 63. So let's start with this left inequality. We need to get the x by itself, so we're going to start by adding 6 to both sides of our inequality. On the left, we're left with 3x is greater than or equal to, and on the right, 9 plus 6 is 15. And now divide both sides of our inequality by 3. On the left, we're left with an x is greater than or equal to. On the right, 15 over 3 is 5. Now we're going to solve the right inequality. So we have negative 7x is greater than or equal to 63. We just have to get rid of the negative 7. It's being multiplied, so we're going to divide both sides by negative 7. Negative 7 over negative 7 is 1, so we're left with an x on the left side. Remember, because we divided both sides by a negative number, we have to flip the inequality sign. And 63 divided by negative 7 is going to give us negative 9. So I'll just bring this down. We get x is greater than or equal to 5, or x is less than or equal to negative 9. And now we just want to plot this solution on a number line. So typically you want to put all the numbers on the number line, but I don't really have space because we're going all the way from negative 9 to 5. So I'm just going to put negative 9 right here, and then I'll put 5 up here. I'm not going to put any numbers between them, but for school, you typically want to put evenly spaced intervals between your numbers. So we found that x can be equal to 5 or greater, so we're going to put a closed circle at 5, and it could be anything equal to 5 or above it, so we're going to shade that to the right. And x can equal negative 9, but it can be less than or equal to negative 9, so we want to shade everything to the left. So this is how we graph the solution to number 4. Let's go through 2 more examples just to make sure we've got this down. For these last 2 examples, I encourage you guys to pause the video and try them on your own, and then you can watch me work through them to make sure that you solve them correctly. Let's jump into number 5. We have negative 10 is less than 1/2 n minus 6, which is less than or equal to negative 8. Our goal is to get the n by itself, so we're going to start by adding 6 to all 3 parts of our inequality. On the left, negative 10 plus 6 is negative 4, so negative 4 is less than. In the middle, negative 6 and positive 6 cancel each other out because they go to 0. So we're left with 1/2 n is less than or equal to negative 8 plus 6 is negative 2. And now to get rid of the 1/2, we want to divide everything by 1/2. So we're going to divide all 3 parts by 1/2. On the left, we're going to have negative 4 divided by 1/2. In the middle, 1/2 divided by 1/2 is 1, so we're left with 1n, which is n. And on the right, we have negative 2 divided by 1/2. And now we need to divide these fractions on the left and the right. We're going to keep change flip. So we're going to keep negative 4 as it is, but put it over 1 to make it into a fraction. Change the division sign to multiplication, and flip 1/2 to become 2 over 1. We have less than n, that's going to stay as it is. It's less than or equal to, and we're going to do the same thing with the negative 2 divided by 1/2. So negative 2 over 1, change division to multiplication, flip 1/2 to become 2 over 1. On the left, negative 4 over 1 times 2 over 1 is just negative 8. It's less than n is less than or equal to negative 2 over 1 times 2 is just negative 4. So we get that negative 8 is less than n, which is less than or equal to negative 4. So this is an and inequality, so this is the same as saying n is greater than negative 8, and n is less than or equal to negative 4. And now we just want to plot this on a number line. Let's go negative 9, negative 8, negative 7, negative 6, negative 5, negative 4, and we'll go up to negative 3. N cannot equal negative 8, so I'm going to put an open circle. N can equal negative 4, so I'll put a closed circle. N is greater than negative 8, so that's to the right of this leftmost point. And n is less than negative 4, so that's going to be to the left of negative 4. So it'll end up being between both of these because it has to fit both restrictions because we have an and. So that's how you graph n is greater than negative 8 and n is less than or equal to negative 4. And finally, looking at example 6, we have a over 2 plus 1 is greater than 5, or 4 minus a is greater than 15. So we're going to solve each inequality separately. So we're going to start with the one on the left. We want to start by getting rid of this plus 1. So we're going to subtract 1 from both sides of our inequality. On the left, we're left with a over 2. And on the right, 5 minus 1 gives us 4. We want to get rid of this 2 that's being divided, so we're going to multiply both sides of our inequality by 2. On the left, we're left with 1a, which is just a, is greater than. On the right, 4 times 2 is 8. So for one part of our answer, we get that a is greater than 8. And now we want to solve this right inequality. So we need to get rid of this 4, and then we'll have to get rid of the negative in front of the a. So we're going to start by getting rid of the 4 by subtracting 4 from both sides of our inequality. On the left, 4 minus 4 is 0, so we're left with negative a. On the right, 15 minus 4 is 11. And now to get rid of this negative, we can divide both sides of our inequality by negative 1. Negative a divided by negative 1 gives us a positive a. We divided both sides by a negative number, so we flip the inequality sign. And 11 divided by negative 1 gives us negative 11. So we get a is greater than 8, or a is less than negative 11. And we're going to graph this on a number line. Because the numbers are so spread out, I'm just going to graph the two numbers, so negative 11 and positive 8. We know that a could be greater than 8, so we're going to put an open circle at 8. And it can be anything greater, so we're going to shade to the right. Or a can be less than negative 11, so it can't equal negative 11, so we put an open circle. But anything less, so we shade to the left. So this is how we graph a is greater than 8, or a is less than negative 11. So hopefully that helped you guys learn how to solve compound inequalities. You just have to remember to basically solve them the same way you solve normal inequalities, But when you have a three-part one like number 5, you just have to remember that anything you do to one part of the inequality, you have to do to the other two.